In the dim outskirts of our solar system, nearly 1 billion miles from the Sun, drifts one of the strangest worlds we've ever found. Titan, Saturn's largest moon. It's a place both alien and hauntingly familiar. The only other world where rivers, lakes, and seas ripple across the surface. But here, the lakes don't shimmer with water. They glisten with liquid methane and ethane, flowing in temperatures so cold that air itself could freeze. At -179 degrees Celsius, Titan's landscape hosts a completely different version of Earth's hydrological cycle, one powered not by water, but by hydrocarbons, a mirror of our world, in a chemistry utterly unlike our own. The mystery began with Voyager 1's flyby in 1980. As it passed Titan, its cameras revealed a thick orange haze, a chemical fog that hid the surface from view. Beneath that haze, the data told a fascinating story. Titan's atmosphere was rich in nitrogen and methane, its surface pressure higher than Earth's, its temperature low enough for methane to exist as liquid. Scientists began to wonder, could there be oceans down there? Vast alien seas of liquid gas pooling under the orange sky? Voyager left us with a tantalizing question that would take decades to answer. In 2004, the Cassini spacecraft entered Saturn's orbit, and from it, a small probe named Huygens began a daring descent into Titan's atmosphere. For more than 2 hours, Huygens drifted through orange clouds, its cameras piercing the haze for the first time. Below, it saw winding river channels, frozen highlands of water ice, and dark plains shaped like ancient flood basins. Then Huygens landed softly on Titan on January 14, 2005, atop icy pebbles dusted with methane frost. It was humanity's first touch on a world beyond the asteroid belt, and the first glimpse of Titan's hidden landscape. Cassini's radar soon unveiled what Voyager never could. In Titan's far north, vast, smooth regions appeared dark in radar images, the signature of liquid. By 2007, the truth was undeniable. Titan was home to lakes and seas filled with liquid methane. It was the first time scientists had found stable bodies of surface liquid anywhere beyond Earth, a discovery that redefined what it means for a world to be alive with activity. At Titan's North Pole lie the great methane seas, Kraken Mare, Ligeia Mare, and Mare. Kraken Mare stretches across 500,000 square kilometers, larger than the Caspian Sea, and plunges hundreds of meters deep. Ligeia Mare, slightly smaller, is rich in pure methane, while Mare nestles nearby like a dark frozen lagoon. Together, they form a connected network of alien oceans, tides and currents swirling beneath the perpetual twilight. Their mirror-like surfaces reflect the faint sunlight that filters through Titan's golden haze. Far to the south, Ontario Lacus glimmers under the dim glow of Saturn's light. It's smaller, about the size of Lake Ontario on Earth, but its chemistry is different. Here, methane and ethane mix equally, shaped by slow evaporation and polar winds. Around it lie ancient dry basins, ghostly remnants of vanished seas. Some small lakes on Titan even sit atop hills, their steep rims hinting at explosive origins. Perhaps formed when buried nitrogen suddenly vaporized, blasting craters that later filled with methane rain. Titan's atmosphere hums with a rhythm all its own. Methane rises into the sky, condenses into clouds, falls as rain, and flows into rivers, only to evaporate again beneath the weak sunlight. It's a living cycle, just like Earth's, but with completely different chemistry. The rain here isn't water, it's liquid natural gas, and beneath Titan's orange clouds, rivers of methane carve channels through frozen plains of water ice, creating landscapes eerily similar to our deserts and deltas. But there's a problem. Titan's methane shouldn't exist anymore. Sunlight slowly breaks it down, destroying it over millions of years. So where does all this methane come from? The answer may lie deep beneath the surface. Some scientists believe Titan's interior holds reservoirs of methane locked in icy cages, released through cryovolcanic eruptions, where cold volcanoes spew not lava, but liquid methane. Others think underground seas slowly exhale methane into the atmosphere, replenishing what's lost. Whatever the source, something inside Titan is alive, geologically, if not biologically. Titan's seas are not still. Cassini saw mysterious bright patches appear and vanish on Ligeia Mare. Magic islands, as scientists called them. They could be waves stirred by Titan's gentle winds or bubbles of nitrogen gas rising from the depths. Recent studies show that even light winds, barely a breeze, could create small waves in Titan's dense atmosphere and low gravity. And as Saturn's pull raises tides across the seas, currents may swirl through narrow straits, connecting Kraken and Ligeia Mare in a slow, alien rhythm. Every 29 Earth years, Saturn completes one orbit around the Sun, bringing long, slow seasons to Titan. In northern summer, sunlight warms the seas just enough to trigger evaporation and methane storms. Vast clouds bloom, pouring rain across the poles, filling lakes and flooding river channels. Then, as winter returns, the methane condenses again, the air clears, and the lakes slowly shrink. Some even vanish entirely, drained into Titan's porous crust, waiting for the next cycle to begin. Titan is more than a moon. It's a time capsule. Its chemistry may mirror the early Earth before life began. Complex organic molecules form in its skies, rain down onto the surface, and collect in pools rich with carbon and nitrogen. Scientists wonder, could life begin in such a place? If impact events or cryovolcanoes once melted parts of Titan's icy crust, liquid water might have mingled with organics, sparking reactions that resemble the first steps of biochemistry. And deep below, an ocean of water and ammonia might still churn, a hidden sea where simple life could, in theory, survive. Even more radical, could life exist within Titan's methane lakes themselves? It would need a chemistry completely different from ours. Cells made not of water and fat, but of hydrocarbons and exotic membranes. Experiments suggest that under Titan-like conditions, tiny droplets could form structures resembling primitive cells. If so, life here might breathe hydrogen instead of oxygen and exhale methane instead of carbon dioxide. Such life would challenge everything we think we know about biology. In the coming decade, we'll return to Titan, this time to explore its surface from the air. NASA's Dragonfly mission, a nuclear-powered drone, will soar through Titan's thick atmosphere, landing at multiple sites to study its chemistry and search for signs of life. It will fly from the dark dunes of Shangri-La to the icy plains of Selk Crater, a place where water and organic compounds once met. Dragonfly will be humanity's first flying robot on another moon, and its eyes and instruments may finally reveal whether Titan's chemistry ever crossed the boundary into biology. In many ways, Titan is Earth's distant twin. Both have thick nitrogen atmospheres. Both have rain, rivers, and seas. But Titan's sunlight is dim, a pale glow filtered through a golden haze. Its mountains are frozen water, its sand dunes made of carbon, and its lakes shimmer with methane. Standing there, under that orange sky, you'd see a world that feels both alien and heartbreakingly familiar. The lakes of Titan remind us that life's potential reaches far beyond Earth. Here, under the cold light of Saturn, chemistry dances in ways we're only beginning to understand. Titan's methane cycle proves that even in the deep freeze of space, a planet can breathe, rain, and change. And somewhere beneath its frozen crust, perhaps, lies a spark, not of fire, but of possibility. Titan stands as a bridge between what we know and what we've yet to imagine. A world where the line between science and wonder begins to blur.